Hi everyone, welcome to my channel. My name is Berkin Mert Coşan and I'm a student at Berkin Mert University's Electrical and Electronics Engineering Department. Today I want to show you my EEE212 term project, which is called Nuclear Weapon Key Producer. Before presenting the project, I want to talk about my components. Let me introduce you my components. I use breadboards. I mainly designed the circuit on this breadboard. I have a keypad. There is also a fingerprint sensor. There is a button for the interrupt. There is an OLED screen. And also there is a KL25Z freedom board. And we will use the SDA sensor on it. And also there is two code sections. One of them is C part. Actually the main logic was written in C on ARM and it is embedded to this freedom board device. And there is also a Python code for the user interface. This Python code will be used. There is UART and I2C in my project. UART is used for the communication between the Python part and C part, and I2C was used to communicate between this fingerprint sensor and C code. Now let's talk about the logic of this project. Actually, the logic is we will produce 16 4-bit nuclear weapon codes in order in the emergency situations to send the nuclear missiles, and these codes will be used for the security. Only the authorized person, like the government person or the authorized people in the army can be used these codes in order to send the nuclear missiles to desired places. For this, let's start. We will. There is two-factor authentication. Now I will run the code on Python, and it says "Welcome to Nuclear Missile Control System." Press the button to create a log. Now I will press this button and activate my interrupt. It says slide your finger around the touch sensor to generate randomness. As you can see, as I said, I will use the SDA sensor on the freedom board. As it can be seen, it generates 16 keys. As I touch my finger to this board, when I didn't touch, as it can be seen, it doesn't generate any key. Now I'm continuing. Now it generates 16 4-bit security password, and it says enter a 4-digit password and press hashtag. Now as you can see, I will set a password. Let's call it 7777, and I pressed hashtag. Now we enrolled the 4-bit key for security. This is the first step of this authentication. Now it says now your fingerprint will be enrolled to the sensor. Touch your finger to the sensor. Now I will enroll my this finger. It says remove finger. I removed and again pressed. Now it will turn green. It turned green and it says control system is ready. Press the button to unlock. Now it also enrolled my fingerprint. As I said, press the button to unlock. Again, I activated my interrupt. Scan your fingerprint to unlock. Now I enrolled my this finger and I will use my this finger. It declined. It says the fingerprint didn't match. Try again. And I use this one. And also fingerprint didn't match. Try again. Now I will try with my enrolled finger. And it says fingerprint match. Enter the 4-digit password and press hashtag to unlock. Now I get the keypad and we set it 7777 password. Now I will try a wrong password. For example, 7779, and I press this. As it can be seen, it says password didn't match. Try again. By the way, we are in the half of the authentication. We activate the first step with our fingerprint and the LED turned yellow. It was red before the before the fingerprint match. Now I will again set a wrong keypad password. Again, it says password didn't match. Try again. Now I match the true password, which is 77777. Now it says dumping the nuclear missile key. Dump nuclear keys are these are the 16 generated 4-bit key with using this SDA. And since we passed these two-factor authentication, the LED turned green. It means that we reached these keys and it is ready to send the nuclear missiles to desired places. And again, it says press button to unlock. Now I again use my interrupt, and it locked and the LED turned red, which means we locked again the system in order to not send these codes with unauthorized people. This was my project. Thanks for listening.